welcome to our talk about simplification of data pipelines by containerization and how Spark and Kubernetes and containers work together. Some words about us too. So I'm Rebecca. I did my PhD in molecular biology and worked a lot with signal transduction pathways and networks. And this is why I now at Zoe work with the implementation of graph databases with ontology, knowledge graphs, and such fancy stuff.
I'm working at Zoe as a data scientist and as a data engineer, and I have studied mathematics and focused on time series analysis. And at Zoe, I'm trying to figure out how you can use new technologies like Kubernetes and Docker to simplify your data science task.
And here's a short outline about what we are talking today. So first, we will give a short introduction to data science and the analytics capabilities, and then we will jump into Spark and Kubernetes, and we will have a wonderful live demo how they work together.
It's really live on GCP, so keep your fingers crossed that everything is working, and I'm excited a bit.
Will work, for sure. And so here we are in the development of data science. So it all begins with purpose-oriented analysis of data. So in the very beginning with mathematics and statistics, which developed, of course, in the whole thing of mankind. And then we have the progress in economic sciences as well. So when we had the first mergers, they want to know better about the products and everything. So we had that, some progress. And then the last century, we had the emergence of computerized data analysis, which gives us a lot of possibilities to analyze these data which come together. And then we had the technical progress, which made it much cheaper, because before it was very, very expensive with slow processors, very high costs for storage and stuff. And now we have this technical process which makes it possible to do this data science and to integrate all the information. And this is basically what is data science about. So it's not just one subject, but we have here the old stuff with mathematics and statistics.
That's me, the mathematician.
Exactly. And we have a lot of domain and business knowledge which has to be integrated, because we want to give more value to the businesses, for example, and to give them new possibilities. And this does not work just alone, but we need the new subject of information technology, which comes now into play. And we have different tools like traditional research, software development, and machine learning, which all combine these subjects together to be able to do this data science. But what are the other analytics capability of data science? So this is what you can see here. So at the very bottom, we have the descriptive part, which is just business intelligence and which answers the question, what happened? So it might just describe, for example, that a marketing campaign went good or bad. And the next level is then, of course, the logical question, why did it happen? So why was this marketing campaign good or bad? And then you can evaluate and make better decisions for future. And this can also be facilitated by this predictive capability. And this also is here involved in this optimization. And this tells you what will happen, so that you have this really predictive forecast which tells you what might happen, and then it's easier to do the right decisions. And the ultimate goal is basically not just to predict something, but to automatically trigger what should happen. So this can be, for example, that it gives you an output, okay, please do that, this will lead to that, and therefore you will have a good outcome for the business. But this can also already trigger some action and just inform the people who should usually decide but do not decide anymore. They just get informed of what happened. And there is one very nice thing that it already happens, because, for example, our CEO once tried to order some gadgets from the US for our company, but it was just not possible to get it because it was detection as fraud, because it was from Europe, and some strange one who tried it with different email addresses, and it just did not work because it was detected as fraud. And so here we have this prescriptive part already working. Yeah, but what is data science? So we have this ultimate goal of taking all these things together, and it's data science. So it's science about data, and this means we have a hypothesis about all the collected data we have, and basically we have to do experiments. So it's not just one experiment, because one experiment is no experiment. It does not prove anything. So you have to do an experiment again and again and again and adjust it. And after the adjustment, you finally get a learning if a model works or if it's good or bad and something like that. So you have to do very fast development cycles. And this is what you guys already know from software development with your CI/CD methods, where you also get these circles. And this is what we also have here in data science.
Yeah, and my part as a data scientist is to look at you guys and see how you are using these CI/CD pipelines. And yeah, I was looking, how can I integrate these pipelines into my machine learning task, into my data science task? Yeah, and that's what we're going to talk about. So let's focus on the tools we are using. The important tool for big data processing is Spark. You can say it's the Swiss Army knife for big data processing, and it's a distributed system, and it's processing mostly in memory, so it's very fast, and it combines a lot of things in it. You can process batch and streaming data, and from the beginning of transforming the data, analyze the data until the machine learning task, you can do everything with it. So it has a really broad machine learning library in it implemented, and that's pretty cool, and also graph processing. It's very easy to use because you have a lot of high-level APIs, and you don't need to code so much lines because it's already implemented. And if you prepare coding in Python, R, or Scala, it works in Spark. So yes. What's also very helpful is that you can program and code everything locally and runs it, and then just execute everything, submit everything on the cluster, and it will run. Spark will make sure that everything is working in the cluster for you.
So Spark is a distributed system, but how does it work as a distributed system? And here we have, for example, the driver who starts a Spark session, and we have the cluster manager who gets the request from the driver, and the cluster manager then sends a request to the workers and asks for resources. And then we have the workers who say, okay, I have the possibility to work something, and they responded back to the cluster manager, and then they are assigned to the driver. And the driver then can assign the tasks to them, and the workers do not have to do anything else than execute the tasks and respond the status basically back to the driver. And for the cluster manager, we have different ones, as we heard from Craig McLuckie before. So we have Yarn, we have Mesos, we have Standalone. But the nice thing is that we can use Kubernetes. And Kubernetes is also a distributed system and an open source container orchestration framework, which looks like basically the same, or pretty similar. So we have the master node and the workers, which are here the kubelets with the pods, which comprise one or several containers. And it's also this master-slave principle. And if you look now, back and forth again, you see that they really look pretty similar. And so very skilled people might think, okay, it might be a good idea to combine these, and especially the ease of handling them both for using several containers and to do some experiments for us data scientists. Because here as data scientists, it's pretty good to have the containers, as we have the benefit of portability. So I do not have to care if it runs locally or in the cluster. It runs in both. And also, for example, if I, by myself, want to try different experiments, I can just use different containers. And also, I can try different things than my team members. And also, I do not have to ask my ops people to always set up a new framework for doing my experiments. So this is also quite easy then.
Yeah, I think this is the most important thing for me, because I don't want to make a ticket and ask somebody if he can install something on the cluster. I just want to try something out, try a new algorithm out and test it. And yeah, with containers, it's more easier.
Yeah. And then, of course, we have also the fortune of having a shared kernel with other containers. And basically, all these points lead to very fast development cycles, which is quite nice for us because it works quite fast that we have to test something. And if an algorithm just does not fit, then we can just change and adjust parameters and stuff. Yeah.
So me as a data scientist, I really should adopt these containers and use them in my workflows. But why should I now use Kubernetes as a cluster manager? One thing is that is like a Spark, it's going to be the thing that is used in production now more often. And what is also very good is you have all these managed services on the cloud, on GCP, on AWS, or on Azure, where you have these managed Kubernetes services. And they all look the same. It doesn't matter if you're using it on the cloud or on-prem. It's very easy to use it. And what is also very good, if your web server is running on Kubernetes, and why shouldn't my machine learning application also run on Kubernetes? It's more practical if you have one uniform interface to your cluster, because therefore you can improve your infrastructure utilization and also then reduces the operational cost. So
and I think to run it basically also in containers in the cluster is also very good because it should also be embedded in these applications. So you should also have it in this whole surrounding.
Yeah, it's very easy to use. But we are talking too much blah blah now. I think we have to focus on more practical things and jump into the demo part of our presentation.
Yeah.
And we have prepared a machine learning touch with this. This is a data set from Kaggle. It's called a Smart Meter London data set, where in London we installed some smart meters to collect the energy consumption from some households. And our aim is now to estimate the function f, which predicts from a given input an output, the energy consumption. And we will do this by using some features like the hour on the weekday, because on energy consumption there are some daily patterns in it.
And this is actually very interesting. So we are here in this predictive part where we say what will happen. And this is very interesting in regard to energy consumption, as for example, the energy peaks, which come when you do not have that much energy consumption, that you, for example, have then a skip in the market prices, for example. And also the companies are already thinking about how to store the energy. So this prediction is in this regard quite interesting.
And this data we have is time series data. And that means that for every time point, you have the energy consumption. And yeah, you can then predict based on some past energy consumptions. So yeah, let's talk a bit about how this is working when you want to predict something. It's not just looking into a crystal ball and then the prediction is. It needs a bit more. It's just a cycle of development. You first have to load the data, then transform it, create some features that are appropriate to predict, and then you have to split your model into training and test data, then train your model and test it, and don't forget to evaluate it and see if it's really working good on unseen data. And often it's not that you've tried out one algorithm and everything worked. No, it isn't. You have to iterate through this cycle a lot of times. And sometimes it's a bit frustrating because you don't have success, but when you have success. It's really great because, yeah. So perhaps when the algorithm isn't working, you can try out to create new features that are better, or perhaps use another algorithm that is more appropriate for the data, or you can hyperparameter tune your parameters. So yes, there are a lot of possibilities you must do to get success in this. Now let's see what technologies we are using in our demo. I commit all my code in a Git. So we're using now here GitHub. I have created a Git repository where all my machine learning code is in it, and also where the data is, and where I have written a Docker file to get later everything working on Kubernetes. And I have created on container registry on GCP, you can create some triggers. Whenever you make a Git commit with a tag, then a Docker image is automatically created. And yeah, that's really simple. I will show it in a few minutes. And when I now want to run my machine learning algorithm, I just make a Spark submit, and then the job is submitted on the Kubernetes cluster, and the pods, the driver pod and executor pod for Spark are built and uses the Docker image I have created from the GitHub. So here you can see the cloud-built YAML file to build a trigger in the Google Container Registry. The Google Container Registry, I'm not sure if everybody knows it, it's a private Docker registry in the Google Cloud Platform. And there you have the possibility to create building pipelines to create some Docker images. And it's very easy to define these pipelines. You just have to say here, build the Docker file. You can specify here the name, where it is. And in my case, it's in the source directory where my GitHub is. And then here you create the Docker image. So yes, just a few lines of code and very helpful thing. So now let's go into the demo. Here is the Cloud Shell, where I have got a terminal to later where I will type. So here is all my code that is also on the GitHub. This is my GitHub repository, which I have created. And you can use it later to test it on your own. And here is the container registry with all the Docker images in it. This is the one I will use later. And I already had set up a running Kubernetes cluster because it took some minutes that everything is working. So now let's do a git tag and see if the Docker image is automatically created. I have already checked out my GitHub repository, and I'm now in the correct directory. And now I just check how which tags I already have used. So it's 13. So now we just make a git tag 14.0, and then make a git push origin master with the correct tag. And it's created, and let's look at the GitHub if the release is there. You can see it, it's here. So now let's see if the image is created. We are now here once again in the container registry. Here is the build history of my Docker images I have created. And you can see here's a lot of lists because I tried out a lot of times to get it working. And whenever you get a green bar with a check in it, it succeeded. But sometimes, it doesn't work because perhaps you have an error written in your Docker file, this could also happen. And here, when you have this blue cycle running, you see that it's in progress and it's building the Docker image of a Docker file. So yeah, you have here, I have 2 main building steps in it. The first step is the Scala SBT step, because I have written my machine learning pipeline, this thing with loading the data, transform it, creating features, and train test model thing. This was written in Scala, and you first have to compile it. So this is the first task, and it will take some minutes to finish. And the next step is the building of the Docker image. Perhaps I can show you the code of the Docker image. So here's my Docker file. The first line is that that my Docker image inherits from the latest version of the Spark image. It's Spark 2.3, where it's natively allowed to use Kubernetes and Spark. Yes, of course. Sorry, better now? No? Now? Okay, perfect. All right, so here it inherits from the latest Spark version 2.3, and you just add some jar files for the machine learning task. And I'm also here adding the data to the Docker image. There, and that's it, just a few lines of code. And it's no problem to add there some custom packages if you need them. So yeah, let's look if it's completed. Perhaps no, it isn't. Okay, you can inspect also here the logs if you want. So inspecting the logs is always good if something isn't working. Yeah, perhaps I can show you about the build trigger now. So here I have, it's very easy. You just click add trigger and then define that you want to use GitHub, and then yeah, just link your GitHub repository. And here I have created a trigger that whenever I make a push tag, then the image is automatically built. And here I have specified. Here you can see that I have specified a cloud build YAML file, which I have shown you before. So, yeah, it succeeded. We got build successful. So, yeah, it just took 3 minutes to build automatically the Docker image. And the next part is also quite easy to do. You just have to, you need a running Kubernetes cluster. Just one line to set it up. The only thing you have to ensure is that your cluster is big enough to run the Spark job. So I have created here a cluster with 3 nodes, and I have specified the type is N1 standard -4, so that yeah, it's big enough. And my cluster is running in Frankfurt, and the next thing is that you have to ensure that you can connect to your cluster, so you need some credentials. And yeah, that's the first thing. I have set it up before. And then you also have to yeah, make a, you can use kubectl to connect to your cluster, and just yeah, use a proxy to connect to. And what is also might sometimes be important to do is that you must have the correct RBAC role set to your Spark driver pod, because the Spark driver pod must be able to create some executor pods, and this is what I have done here with this role binding thing here. It's yeah, and it's also later added to the Spark submit where you specify the service account name you have created. And the Spark submit to run the machine learning task to predict the energy consumption. Here it's just a few lines. You can specify there which algorithm you want to use. I have implemented already 2 of them. First one is the linear regression, which you might know from school, that you're fitting a straight line to your data. And the other algorithm is a random forest regression. Random forest regression is an ensemble method that uses multiple decision trees to make the prediction. And so here just specify how much executors you want. I want 3 Spark executors, and you can also give the driver pod a name, so it's later easier to access it and get the logs. All right, so let's submit the Spark job. I'm then going to the Cloud shell once again, and now I'm here in the directory where my Spark is installed. Perhaps I can make a short kubectl cluster info to see if the cluster is running. Here it is. So, and perhaps we can look if we have already some pods. Kubectl get pods show minus all. Oh, mistake. No, I haven't got any pods. All right, so now we can just submit the first machine learning task. So do the linear regression now. Where it is, here it is. So I just type in here the new tag of the image we have created. It was 13.0. So I just copy here this submit command and paste it in. And
now the magic happens.
Yeah, magic happens. It's something working, it's pending. So we can perhaps inspect what pods we have. Kubectl get pods. Yeah, we see here we have the driver pod and also 3 executor pods, which are all running. So perhaps look at the logs. Get logs. No, it's without get. So just kubectl log minus f, and then specifying the name of the driver. And here it comes in why it is useful to give the Spark driver pod a name, because if you don't do this, you're getting a lot of numbers, and here you just have to do a get pods to know which name your driver pod has. So here it's lr minus demo. And here a lot of logs are listed. And here it is. This is our result, because I have trained the model on some test data, and then I have trained it on some training data and then tested it on some test data. And now I need a metric to see how good is my algorithm working. And here I use the root mean squared error. This is often used when you have a continuous prediction. And this number means that the closer you are to 0, the better your algorithm is. So, yeah.
Yeah, because the more to 0 the error is, the smaller the error is, and therefore the better the prediction is. Because when you have no error, there is no error in the prediction, and then it's fine. And this is our, what we want to get.
Yeah,
and to achieve this, we have to do experiments.
Yeah, but I think getting no zero error is impossible and not useful, because then the algorithm won't generalize well. So yes, we're satisfied with something very close to zero, but perhaps yeah, 0.5 is not so satisfying for me. Perhaps it's getting a bit better, and we can try out if we can do this better with the random forest regression. So here I just, because the random forest regression is also a library of Spark, so I just have to change here the name of the application of the algorithm. And here we want to use the newest image. And just do it once again and look, or not in the right directory. That happens often. So you must be sure when you're doing the Spark submit that you are in the directory where your Spark is installed. Now it's running once again. We can perhaps inspect once again the logs. So the new name is now RF, or random forest. And now automatically the driver pod, the executor pod, and everything is deployed and working, and you have nothing to do. Just run a Spark submit, and the magic happens.
And wait for the result of the second experiment.
Yeah, and now we're a bit better. So yeah, that's great. I'm happy with that. And
so the error is smaller, the model is better.
Yeah.
And now you can do it again and again and again until you get your best result in this regard.
I think also you guys can do it on your own, because it's so simple to do it. You don't need so much time to deploy all these things, because it's just a few lines of code, and you can try out changes very quickly. Just add some new lines in your code, or just do some more feature extraction. It's very easy to do this, and you can do this oftentimes how much you want it. So yes, just go on our GitHub repository and try it out.
Yeah, and just keep in mind that it's important to get a low error, because when you want, for example, to do this prescriptive modeling, so when you really finally trigger an action, instead of a human who sits in between, the machine triggers an action and decides for you. You really want to be sure that it is good. And therefore, we want to achieve a good result in this regard. Yeah. And now, finally, just some words to our company, which we are working in. So our company is called Zoe, which is the abbreviation of 0, 1, infinity, or digital DNA. And we are an IT consulting company with offices in Stuttgart and Berlin. Yeah, and we are a quite young team with, as you can see, computer scientists, electrical engineers, mathematicians, physics,
biologists.
Exactly. And we love, for example, to do things in the cloud, to work with clusters, to handle data, and also to bring new technologies to our customers. Yeah, and this is what we love to do. And now, we thank you very much for your attention.
Yeah, so if you have any questions, you can just write us an email or use my Twitter handle. Or, we're here on a conference, so feel free to ask us if you are interested, perhaps in more deep in the machine learning algorithms, or how we are deploying these things.
Yeah. In kind of doubt, we have our T-shirts with 0, 1, infinity, so you will be able to identify us, I think. Thank you.